Hello, and welcome to the second video of the series. We're going to write our very first Hello program, and this is just a window from the previous video that we created where we just simply look at the Tinkercad interface for programming Arduino. So if we will rename this to Hello World, if you click in the search window and you search for Arduino, come up with various options. I particularly like this one with the breadboard. So you drag and drop it on there. What you notice is that the 5-volt of the Arduino is connected to the plus sign of the breadboard, and on the other side it goes all the way up to the plus as well, and then you've got the grounds being connected to each other all the way down to the ground pin. So if this is the first time you're using an Arduino board, or you've seen an Arduino board, just zoom in. But thanks to Tinkercad, we've got 3 connections. So when you click your start simulation, you notice that the USB gets plugged in and you get bars provided to it. So on the Arduino board, you've got the transmit and the receive LEDs to indicate when these 2 pins are busy, mostly when by default, when you're actually using the transmitting from the USB connection, in this case, programming the board. But most of the time, you can also use this for serial communications, like communicating via Wi-Fi or other form of communications. So it's advisable not to use these pins for various programming unless you really have to, using the wire function as well. So on the Arduino, you've got the reset pin for the pin where you press and then reset. It becomes active once you start your simulation. So you can see the reset pin actually working on there. And in this case, each time I press the reset pin, you see the onboard LED being refreshed. So here you've got an LED that comes with the Arduino Uno board that you can use. So you don't necessarily need a peripheral LED, or the only LED you need is one. And you've got your digital pins connected on there. So from you've got pin 2 to pin 13 as your digital pins that you can use. You've got 3 grounds, 1, 2, 3 ground connections that you can use as well. So each of these digital pins, you notice some of them have the tilde connection in front of them, the tilde in front of them. So the tilde symbol means that these pins can actually use pulse width modulation. So you've got your 5-volt connection on there, and you've got 3.3 volts that you can use as well. So on this side, you've got analog pins, or you've got 5 analog pins that you can use to read analog signal inputs. Pulse width modulations will mimic analog signal. First thing we want to do is to test how accurate this particular simulator is. So let's see. First we put an LED, move out of the Arduinos to basic. We have an LED here. And what we want to do is connect the LED pin. You've got the cathode there and then the anode there, which goes to the voltage signal. The cathode goes to ground, so we connect our cathode to the ground. So you just simply click in a hole and then another one. Then you can change the color to black for convention, and then you connect the anode to the 5-volt. Change it to red, and let's start the simulation. So we've got 5 volts running through the LED dot. Then we notice that the LED blows up. So it says the maximum current that we can have is 20 milliamperes. So the maximum current we can have is 20 milliamperes. We are supplying 5 volts. We need to have put some resistor in there to decrease the current going to it. So if we, thanks to Ohm's law, V equals IR. So to calculate the actual resistance that we need to put in series with this, but with our LED, we are aware that the voltage is 5 volts. So we've got 5 volts, and then the maximum current is 20 milliamperes, which is times the resistance. So to find the resistance, we need to divide both sides by the current. Divide both sides. So I'll cancel that. Given the resistance, so we get a resistance of 250 ohms. If you were using 3.3 volts, the resistance will be equal to 3.3 divided by 20 milliamperes. So it will be divided by 20 times 10, which will give you 150 ohms. Between the 250 ohms resistor and the 150 ohm resistor, 220 ohm resistor is quite common on the market. It's quite a popular resistor, easy to get. So we can use 220 ohm resistor. What we can do is, basically what I've done is search for resistor, or basically drag and drop this. We press R, it will rotate. And resistance on. You can move the wire across as well. So to change the value of the resistance, you click the resistor, and just change the unit to ohms, and you can write a new value to 20 ohms. Notice that as soon as we change the value, the color also changed to reflect the resistance color coding. You start the simulation, and you notice that the LED turns on this time safely as soon as you put it on. Okay, so what we can try is to increase the resistance to see if it has any effect. It's to about 1. You notice that the brightness decreases as well, because the higher resistance, the lower output current that is going into the resistor. So as bright as before, so 220 ideal for us, and that's what we'll be using 220. Now what we have here, we notice that basically you switch on, switch off, and there's no form of control because we simply connected to the main 5-volt connect directly. So we're not introducing any programmability. We want to introduce a form of programmability. So we want to introduce some form of control. In order to get that control, we will be connecting to one of the output pins of the Arduino Uno board, so we can actually use the 18 mega 32HP chip on the Arduino Uno. To do that, we will take the anode and connect the anode to pin 13. Introduce another connection by double-clicking anywhere in it, and then drag across. Let's do some cleaning. Make it look good a little bit. Right. So what we want to do is link the LED. So we go to the code interface. So we switch to test, continue. This is the basic code or the standard code that comes with it. In this particular case, simply click simulate, start simulation. And you notice that we can blink. What it's doing is first, the setup, we set the pin 13 as an output. Then we write a high voltage to pin 13, introduce a delay, and then we switch the LED off on P by sending a load voltage and then delaying for 1 second. So you notice every second the LED will turn off and then go on off as well. So what you notice is that the onboard LED is also blinking here, and it's in sync with the LED that we've connected. This is because the onboard LED is connected to pin 13, as we have declared here. That is why it's blinking. So if you want to see more detailed explanation of the code and then the scope of the Arduino program and how it works, just tune into the next video.